In this video, I'm going to continue our discussions on rational expressions. We will move into how to multiply and divide rational expressions. Now, before we get to that, we will just take a moment to refresh your memories on exactly how it is that we multiply and divide just regular numeric fractions. I just have it is very similar to what you would do with regular fraction work that you would have been introduced to in your middle school years. So if I have, for example, 2/3 multiplied by 9/10, well, the answer to this would be the way you multiply fractions is to simply multiply the numerators. 2 multiplied by 9, 18. 3 multiplied by 10 is 30. And then we reduce that fraction to, they both divide by 6, the numerator and the denominator, so it would be 3/5. Well, another way that you can look at this is you're taking the numerator 2 times 9 over 3 times 10. And now just to try and draw some comparisons to what we're going to do with algebra expressions, rational expressions, is you then factor any of these numbers that are non-primes, meaning that there's other factors besides the number and 1 that divide into them. So for example, 9, you could change 9 into 3 times 3. Here I have 3, but I could change 10 into 5 times 2. Well, then what happens is you divide out common factors from the numerator that also exist in the denominator. So for example, you'll see, and these have to be factors, things it doesn't work with addition, subtraction, but it does work with multiplication. You can divide out common factors. So I could divide this 3 or that one, doesn't matter. That 3 and this 3 would wipe each other out. So that leaves me in the numerator now. Oh wait, I also have a 2 here and a 2 down here, leaving me with a 3 in the numerator and a 5 in the denominator. And again, I'm not suggesting that this is how you should do multiplication of fractions. I'm trying to draw a comparison between how we're going to do it involving rational expressions, fractions involving variables, and compare it with how it works when we're doing these with numeric examples. It is the exact same thing. If I go over to this one, I'm going to say, now it's division. So hopefully you can recall from your number sense and things you've developed over the last few years of schooling that division of fractions involves us changing division to multiplication and taking the reciprocal, where you switch the numerator and denominator of the fraction immediately after the division sign. So the first, notice this one stayed the same. Change divide to multiplication and then take the reciprocal of the fraction immediately after the division sign. And now multiply 3 times 3, 9, 4 times 2, 8. That one does not reduce. So we would be finished. That would be your final answer. Now sometimes we say, oh, do I have to change that to a mixed fraction? No, just leave it as an improper fraction. 9/8. We'll be fine with that. Just a couple more numeric examples we'll look at real quick here so you can see this kind of plays into the factoring thing that I was showing you. Now these examples already have the work done out, but I'll just kind of do it out myself here again. So let's say 2/9. Instead of 9, we could change 9 into 3 times 3. Now that's multiplied. Instead of 15, that's 5 times 3. Instead of 4, that's 2 times 2. Because it's all multiplication involving factors, you could now look for common factors. A factor from the numerator that would divide out a factor from the denominator. So for example, this 2 would get rid of one of these 2's. This 3 would get rid of one of these 3's. So now when you flip things over, you look across here and you say, all I have left is 5. I'm going to go across here. I have 6. Same answer they got, 5/6. So if I was doing a division, I would start out by saying 3/5. Always change divide to multiplication. Take the reciprocal. These are prime already. They don't have any other factors besides the number and 1, so I don't do anything with those. However, 35 could be changed to 7 times 5. 6 could be changed to 3 times 2. And then if I look for common factors, this will get rid of this. This will get rid of this. And when I say get rid of, I just mean that they divide, because 5 divided by 5 is 1. 3 divided by 3 is 1, leaving me with 1 times 7 times 1 in the numerator, 7. 1 times 1 times 2, 2 in the denominator. So factoring out these numbers allowed me to cross out these common factors and get to my answer. All right, so that's kind of showing you how multiplication and division at its most basic level works involving just numeric fractions, which you've all done before. Now what we're going to do is take our knowledge of multiplying and dividing fractions and just apply it to rational expressions, which, as we've learned in our first video, are just fractions that involve polynomials. As stated in the beginning of this unit, being able to factor will be the most critical skill that you have in this whole unit. So if your factoring skills are not where they need to be, I would suggest that you search out some remedial work on just basic factoring, because the better you get at factoring, the more success you're going to have with these rational expressions. All right, so if I look at this one, it's asked me to state any restrictions. Remember, that's another word for non-permissibles, and simplify the following rational expression. So because I've got this fraction in brackets here, multiplied by this next to this fraction in brackets with no sign in between, that is implied multiplication. So it wants me to multiply these two fractions. Well, here's the first thing you're going to do. Every single question, you're going to factor anywhere possible. That's number 1 on the list. Now, sometimes you can't, as you'll see in this one, but there are certainly some instances where you can factor. So if I look at this one, I'm going to start with the numerator. So it's like you have 1, 2, 3, 4 separate questions, and you have to factor each one individually. When I look here, I notice certainly they're all divisible by 2. They also all have a factor of x in them. So the first thing I'm going to do is just take the greatest common factor of 2x. That will leave me with x squared plus 5x plus 6. Factor the denominator, also a GCF of 2x. Multiply that by x plus 7. I'm just going to put here multiplied by, I'm not going to use the brackets. X plus 7 is already in factored form. It doesn't factor any further. So that'd be equivalent to, like, in numbers, it's a prime number, so that's non-factorable, doesn't go any further. X squared subtract 9 would be difference of squares. X subtract 3, x plus 3. All right, good start. The only thing I do notice is that this expression here will factor again further, because I could multiply to get 6 by using 3 and 2, and then 3 and 2 added together give me 5. So I'm going to have to factor here one more time. So 2x, this one factors further. X plus 3, x plus 2, 2x, multiply that by x, oh, I forgot my x plus 7, x plus 7 here, x plus 7 here, x minus 3, x plus 3. All right, so I've factored everywhere possible. That's number 1 on the list. And again, they have to be factored completely, not just one step like this one here. I factored it, but then it factored again. So that's what they mean by factor completely everywhere. Number 2 on the list, if asked, is identify any non-permissibles, which it says here, or restrictions. So to do that, you need to remember that you're not allowed to have 0 in the bottom of fractions. So you simply go across only the denominators. So I'm only looking at the denominators for these non-permissibles. I've got 2x, and I say to myself, what would make the denominator 2x, that factor becomes 0? What would I fill in for x to make that, what I've highlighted, become 0? Well, in this case, it would just be 0. because 2 multiplied by 0 would give me 0. So there's one number that x cannot be. X cannot be 0. So these are just your non-permissibles. And the way you write, you put x cannot equal. So I said x couldn't be 0. Go to the next one. So what would I put in for x in this bracket that would make that bracket 0? Because if that bracket was 0, I'd have 0 multiplied by whatever this is. It wouldn't make any difference. You're going to get 0 in the denominator, which you're not allowed to have. So in this case, if x was negative 7, I'd have an issue. So x couldn't be negative 7. Keep going across here. So what would make this bracket 0? Well, if x was 3, that would be an issue. And then this one, if x was positive 3, we'd have an issue. Sorry, negative 3. So those would be your 4 non-permissibles. So that's taken care of. Here's the fun part. Once you've got it all factored, what you can now do is divide out common factors. Now they have to be a factor in the numerator with a factor in the denominator. And they can be anywhere, so it could be, you're going to see that in a second, it doesn't have to be within the same fraction. It could be, but this one will cross out this one way over here. As long as it's in the denominator, it'll cross out any factor in the numerator that is the same, provided it is multiplication. All right, now you have to be careful of this because we're going to do addition and subtraction. If this was an addition sign, these would not cross out. It's only because they're all multiplied together which generates factors. So I'll just put here, divide out common factors. Well, as I said, this is the fun part. I have x plus 7 and x plus 7. They are the exact same. I have 2x and 2x. They are the exact same. I have x plus 3 and x plus 3. Leaving me with this bracket or this factor, x plus 2 in the numerator, and this factor down here, x minus 3. Now, just to demonstrate what I talked about with factors versus terms, what will sometimes happen is students will do this, which would be outstanding, but then they'll get to here and they say, oh, I'm going to cross this x out with this x. Now you have an issue. You are not allowed to do that. They said, well, you just did it over here. Look, you crossed these x out. The difference was these were factors. They were things that were multiplied together. This x, because it's subtract 3, makes it what we refer to as a term. You are not allowed to ever cancel terms, things that are separated by addition and subtraction. So those x's do not cancel or divide each other out. I'm just going to get rid of those red lines. I'm not allowed to do that. Oops. There. So our final answer now, our simplified version here, you just go across the numerator and say, what do I got left? I have left, this is my answer. That, so when you cross things out, remember you're getting ones. 1, 1, 1, 1, 1. So ones all multiplied together, that's no big issue. The only thing left is that factor. And in the denominator, the only thing that's still left over after I've divided everything out is x subtract 3. So this expression here is the simplified version or the answer of what you would get when you multiply these two fractions, just like you would do with numbers. I'll give you an example of the value in doing this. Let's suppose I say, well, I wonder if x equals negative 2, what this expression would actually give me for an answer. Well, one way to do it would be to go up here and put negative 2 in for all the x's, put it in your calculator, get this fraction, get the number for this fraction, multiply them together and get an answer. Well, if you use the reduced version, I could do the exact same thing. Put negative 2 in this answer. I'm going to get the exact answer I would have got by putting all these different x's in up here, all as negative 2 as well. So the simplified version is a much more concise way to get the value of an expression. All right, so there's your first example of multiplying rational expressions. So I'm just going to do a series of them here now for you, multiplying and dividing. Remember, to divide, you just simply change it to multiplying by the reciprocal. And you'll see when I run into a few examples of that. So let's go through a few quick examples here. All right, so this one I see is dividing. So it's also got state any restrictions. Remember, that could say state any non-permissibles. It would mean the same thing. So we always start these by factoring. X plus 7 doesn't factor. Difference is squared. We saw this one on the last slide. So x subtract 3, x plus 3. I'm going to leave it as divide for now. Factor this one. x multiply to get 14, add to get 9 would be x plus 7 and x plus 2. The denominator has a GCF of 3x, leaving us with x subtract 3. Now, non-permissibles. Listen carefully to what I have to say here. If you're doing non-permissibles when you have division, because this fraction here is going to get flipped over, the reciprocal taken of it, you must check both the numerator and denominator for what numbers you could put in for x that would make either go to 0. This fraction is not getting flipped over, so I'm only going to look at the bottom. X could not be 3 or negative 3. I'll just put plus or minus 3. That would make either of those 0. In this one, x couldn't be 0. X couldn't be 3. Well, I already have it, so I don't have to put it down again. However, this fraction, when you change divide to multiplying, we're going to have to take the reciprocal of it, which means flip it over. So when I flip it over, I couldn't have 0 here either because that would make 0 go to the bottom. So therefore, in this one, x couldn't be negative 7 either, nor could x be negative 2. Because those two numbers would make the numerator 0, which would then in turn, when I take the reciprocal, make it undefined. So when you're flipping a fraction, you must check both numerator and denominator for non-permissibles. That's the only time. So notice here, I didn't check the numerator. Now it turned out that negative 7 came out of this one anyway. However, it wasn't because of over here. So there's step 1. Factored. Step 2. Stated all non-permissibles. Last thing, well, in this one I got an extra step. Because I have division, I have to change it to multiplication. So the next thing, I don't do a thing other than change my division, change your division to a multiplication sign, and as soon as you do that, you have to take the reciprocal of this fraction. So the denominator goes to the numerator, just like you do with numeric fractions, and these two factors will go to the denominator. And then, as I said before, this is the fun part. For students that are good at factoring, now they can just clearly see what can I cross out here. That wipes out that. X minus 3 wipes out that. Now this x is a factor because it's 3x. There's no addition or subtraction surrounding it anywhere. But this x is a term, so I couldn't cross those out, leaving me with this for my final answer. In the numerator, I'm left with 3x. In the denominator, I'm left with x plus 3 times x plus 2. You're done. That's your final answer. Now sometimes students say, do I got to multiply those together? No, you do not have to multiply those together. Just leave it like it is. Now you could, and I may say that you might look in the back of the book and I actually did expand those out, but you do not have to multiply these two together. Just leave it like this in factored form. Okay, let's do a couple more quick ones. So the big thing here is if you're good at factoring, this is going to go along quite easily. Here's a couple that are monomials. Now monomials, factoring is never an issue. We need monomials. Notice there's no adding, subtracting, mixing in here, in anywhere here like there is over here. So these ones have a mixture. This is a monomial, this is a monomial, but this is a polynomial, and this is a polynomial. So these ones that are polynomials, they may factor. Monomials do not factor. Okay, so here, the way you can do this, there's a couple of different ways to go about it. You could just multiply like normal. So 25 multiplied by 24. 25 multiplied by 24 is 600. X squared times y to the fourth. Well, they're different variables, so nothing collects together or added or exponents or anything. You leave it like it is. 9 times 55 is 495. Y to the 8th times x to the 7th. Again, they're not the same variable, so they're not going to combine together and add exponents or anything like that. I always like to try and line them up here. So you could put y to the 8th, x to the 7th, but I like to put the x's under the x's. So x to the 7th and y to the 8th. So now it goes back to our first video. This is now just a single fraction and we have to reduce it. So start with 600 over 495. Now when you get these bigger numbers like this, it's really nice to have the fraction button on your calculator. So if you do have the fraction button on your calculator, I suggest you just type in the fraction, 600 over 495. Then you just hit your equal sign. Now it will reduce it. It will give it to you as a mixed fraction. I don't want a mixed fraction, so then you just hit your second function fraction button, and it'll turn it into 40 over 33. Now, if you don't have, most do now have the fraction button, but if you don't, you would have to physically go through and divide these down, divide by 5, and then keep dividing until you get these down to numbers that don't reduce any further. Now, like we did on the first video, I've got an x squared and an x to the 7th. We don't want negative exponents in rational expressions. All I'm going to do is say, this means there's 2x's multiplied together. This means there's 7x's multiplied together. The 2 from the numerator would cross out 2 from the bottom, leaving 5 on the bottom. So why are they on the bottom? Because there's 7 of them here, and there's only 2 of them here. I've got y to the 4th, so there's 4 y's multiplied together in the numerator. There's 8 y's multiplied together in the denominator, so 4 of the y's from here would cross out 4 from here, leaving y to the 4th in the denominator. That one's done. All right, this one's division. Change it to multiplying. A to the 4th, b squared over a, multiplied by 4 over b to the 4th. You could reduce here first, this fraction, that's 4. Very good, it's 4. Or just wait and do all the reducing at the end. Multiply across here. So 4 multiplied by this is just simply 4a to the 4th b squared. Multiply these two together, you're going to get a b to the 4th. Now we will reduce this fraction. The 4 over 1 doesn't reduce, it's just a 4. I have a to the 4th, so that means 4 a's multiplied together, and I have a single a down here. Well, that 1a would get rid of one of the a's from the numerator, leaving me with a to the 3. Now when I do the b's, I have 2 in the numerator multiplied together, and I have 4 multiplied together down here. So these two would cancel out or divide out 2 of the ones from down here, leaving you with b squared in the denominator, because there was more b's here than there was in the numerator. All right, so that's just how you work through them with monomials. Over here, because it's all multiplication, so I'm going to have to, I got a little bit of factoring to do here. Remember, that's always step 1. It wasn't an issue here because they were monomials, but this does factor. So I'm going to leave this one, x minus 3, xy squared, divide. Nothing I can do here. Multiply to get negative 12, add to give 1, would be x plus 4, and x subtract 3. Well, before I even go any further, I can see that this will divide this out because it's multiplication. One's in the numerator, one's in the denominator. They're the exact same factor. Cross them out. That leaves me, when I go across and multiply the numerator, 4x squared, y cubed. I have this multiplied by this, so I'm just going to write it as x, y squared, multiplied by x plus 4. And now, when I go to get my final answer, so the only number anywhere, remember, these are terms, so they're not able to be touched. That's going to stay together as x plus 4. Nothing will reduce any further. However, this 4, I'm just going to leave it, but I've got an x squared, and this is a factor x because it's this multiplied by this, which is then multiplied by this. So this is a factor, and then this would all be considered a factor. Well, this x will cross out one of these, leaving me with x squared. I've got a y squared here, so that means 2 y's multiplied together, and I've got 3 y's multiplied together here. So these two will get rid of 2 of them from the numerator, leaving me with just a single y up there. Now the x plus 4 is still going to be down here in the denominator. Now, as I mentioned earlier, students who don't kind of get their brain wrapped around the difference between factors and terms may get to here and say, oh, why don't you cross the 4's out? Well, the problem is this 4 is a factor. That's not an issue. It's this 4. This 4 is a term. It does not reduce any further. And so why don't you cross this x out with this one? Because this x is a term, not a factor. This one's a factor, but this one's not. So I cannot reduce this any further. Final answer. All right. Let's have a look at this one. It's multiplication. So this one's got a bunch of factoring in it. Personally, because I'm pretty comfortable with my factoring. I really like these ones because they go along pretty quickly if you're good at factoring. PCF, take out 3x, I get x plus 2. PCF of x on x minus 4. That doesn't factor. This will factor, x plus 7, x plus 2. Let's start crossing out common factors. X plus 2 and x plus 2. X subtract 4. X subtract 4. Now, this is where students get messed up here. They look and say, oh, I got 3 x's here and 1 x here. This doesn't mean 3 x's. This means 3 multiplied by the letter x. 3 x's is this. That means 3 x's multiplied together. So I've got a single factor x and a single factor x. They wipe each other out, leaving me in the numerator with a 3 and in the denominator x plus 7. That is the reduced version of those two messy rational expressions multiplied together. See how slick that works if you're good at factoring? Okay, let's go to this one. Well, first thing I notice here is I've got a hard trinomial, and I also notice I've got division. So we're going to have some issues here that we're going to have to deal with. Let's start with this one. On a hard trinomial, you know it takes a few more steps. So what I usually like to do with those ones is just kind of get them factored out first. So I got 20x, 20x. Now what I find students will do is they'll only do step 1 and they won't finish the factoring. So the hard trinomial, you're going to multiply this, you get minus 20. I want to get a plus 4 or plus 1 in the middle. So I'm going to use plus 5 and minus 4. I'm not going to start writing the rest of the fraction together until I'm done this. So now this one will divide by 5, and this one will divide by 4. So 20 divided by 5, 4x. 5 divided by 5 is 1. And this one will be 5x minus 1. PCF, take out x, you'll get 7x squared plus 1. This doesn't factor. Change divide to multiply. Take the reciprocal. All right, cancel common factors. This gets rid of this. This is a factor x. This is a factor x. They're gone. Everything else does not reduce any further. I'm now at this fraction. Okay. All right, here we are, a couple more. These are both divisions. So again, the process is the same regardless of whether it's multiplication or division. You factor first. So the numerator is a simple trinomial. Let's factor that. Multiply to get 3, add to get 4. X plus 3, x plus 1. Greatest common factor down here of 4x. X plus 3. I'm going to change the divide to multiply. Take the reciprocal. 3 obviously doesn't factor. X plus 1 does not factor. And as I said, here's the fun part. That, we'll get rid of that. That will divide that out, leaving me with just 3 over 4x. Finished. All right, this one I have greatest common factor of x. X squared, take away 4. And 2. Now, if you just have an algebra expression like this, it's like numbers. Any number by itself is assumed to be over 1. So when you go to change that to multiplication, take the reciprocal. This would be difference of squares. Now I notice that this is exactly the same as this, so it does cancel out, so I don't have to go any further. But suppose that there wasn't an x squared subtract 4 either here or here, this actually would factor again further. However, because they're identical, no sense factoring them. I might as well just cross them out here. So those are gone. Nothing else that will cross out, so that leaves us with an x in the numerator, 2 here, and then this x squared plus 4. Finished. So you can see, if you're good at factoring, and I know some of you may need to work on that, but that's a skill you're supposed to have when you arrive in pre-calc 11, and I'm not saying that everyone's got to be an expert on it. It'll get better as you do more and more. Okay, this is our finale. This is a mixture of multiplication and then a division here. No different than the way we've done it if we involve just numbers. So all kinds of factoring everywhere. Take out your GCF. So greatest common factor. Multiply to get negative 27, add to give 6, x plus 9, x minus 3. Multiply to get 16, add to give 8. That's x plus 4 and x plus 4. Multiply to get negative 8, add to give 2. X plus 4, x take away 2. Change divide to multiply, take the reciprocal. X plus 8, x subtract 3. This is difference of squares. X take away 4, x plus 4. Let's, for just the sake of showing you, let's do non-permissibles on this one. So let's state what x could not be. So this one, we go across the bottom. So x couldn't be negative 9. X couldn't be 3. X could not be negative 4. X could not be positive 2. X could not be 4. X could not be negative 4, which I don't have, so I'll put plus or minus 4. But also recall this fraction is the one we flipped, so I have to check both top and bottom of that one. So x could also not be negative 8, and x could not be 3, which I already have. So you have all these non-permissibles because I looked at 1, 2, 3, 4, 5, 6, 7, 8. And again, this one I checked both because we had to take the reciprocal. So neither numerator or denominator could be equal to 0. Oops. Okay, so now let's do the fun part. Cross out the common factors. X subtract 2, we'll cross out this x subtract 2. This x plus 4, we'll get rid of this x plus 4. This x plus 4, we'll get rid of this x plus 4. X subtract 3, we'll get rid of x subtract 3. I think that is it. So the numerator, we are left with x multiplied by x plus 8. And the denominator, we have this x plus 9. And we have x subtract 4. And that's it. That would be our final answer. All right. So in your textbook, there are a series of practice questions listed here that you can use to work on your multiplication and division of rational expressions. That leaves us with addition and subtraction. I gave you a week off without any assignments just to kind of get your feet back under you. I know some of you maybe last week was a busy week. So next week we'll run into another assignment again on probably reducing and multiplying and dividing. All right, so enjoy your long weekend.